Suspended over 200 feet above the Loire, the Saint-Nazaire Bridge is the longest in France. To the west of Nantes and facing the Atlantic Ocean, it spans 2.1 miles. In the center, a metallic section of 790 yards held by 72 stays. This was never seen before, a world record during its construction completed in 1975.
Les équipes ont construit un ouvrage optimisé pour résoudre vraiment de grosses difficultés techniques, qui était une innovation déjà à l'époque et qui l'est toujours aujourd'hui.
100,000 cubic yards of concrete, 17,000 tons of steel, 5.6 miles of sturdy cables. 50 years after the start of its construction, this structure continues to fascinate the greatest specialists.
On sait qu'on arrive sur un jouet technique et là on se dit mince, c'est peut-être trop gros comme jouet.
To manage to build such a monument, an extraordinary work site took place at the mouth of France's longest river. During 4 years, workmen, engineers, and craftsmen fought against the elements. Wind and storms from the ocean, tides making the water level vary by 20 feet. And above all, constant river traffic that couldn't be stopped.
J'oublie pas la performance technique, la prouesse technique de l'époque, parce que c'était quand même pas simple de réaliser cet ouvrage.
On the shore, oversized concrete beams were mass-produced and positioned above the Loire thanks to a monumental launching gantry. Steel parts of several hundred tons were sent from all over France, hoisted 200 feet above the void and assembled with surgical precision.
Technologiquement, il a marqué l'histoire du génie civil.
To ensure its longevity, the structure of the edifice is constantly monitored. For 50 years, the longest bridge in the country has crossed the ages and been subjected to the constant assault of water, salt, and wind. Beam resistance, viaduct behavior, tension of gigantic stays. The maintenance of this concrete and steel cathedral is a constant challenge for the civil engineering experts.
C'est une fierté, travailler sur un ouvrage d'une telle ampleur, avec une telle histoire dans sa conception, une telle technique, une telle technologie, c'est des sujets passionnants.
How to build such an imposing edifice in such extreme conditions? How to allow it to cross the ages safely? And how to make it evolve to meet ever-increasing traffic? Dive into the construction of an oversized bridge thanks to exceptional archive footage. An adventure that led to the limits of knowledge, pushing the capacities of materials into their furthest limits, and that would change engineering science forever. The Saint-Nazaire Bridge is a crucial link for the west of France. An edifice that unites the two shores of Loire Atlantique and prolongs the Route Bleue from Brittany to Vendée. To this day, it remains the only crossing of the Loire between the Nantes and the ocean. Without it, crossing the river would require a 62-mile detour. This strategic line provides an essential access to the economic lung that Saint-Nazaire represents, one of the main ports in France and an internationally renowned shipyard.
C'est un ouvrage qui rend un service vraiment essentiel à la collectivité. C'est un patrimoine indispensable au maillage territorial.
Today, 50 years after the beginning of its construction, the Saint-Nazaire Bridge is used by over 11 million vehicles a year. In just a few minutes, they cross the 2.1 miles separating the two shores of the largest river in France.
Les chiffres de trafic dans les années 70 à la construction du pont estimaient en 2025 à peu près 5000 véhicules jour. Aujourd'hui, on est à plus de 30 000 et l'été, on passe à des pointes à 45 000. Donc on voit le trafic a explosé sur le pont de Saint-Nazaire.
But before reaching such figures, there was a long story. That of the construction of the longest bridge in France and the longest cable-stayed bridge in the world.
Ça reste une prouesse technique que d'aller faire un ouvrage dans un site aussi complexe que l'estuaire de la Loire, avec les phénomènes, les problèmes météo, les marées, etc.
To cross the estuary of the country's largest river, the construction teams had to do what had never been done before. The conception of this colossal edifice was a challenge. The structure had to withstand constant road traffic and face winds reaching up to 75 miles per hour. As if that wasn't enough to bear, it also had to span the Loire without impacting one of the busiest waterways in France. Here, gas carriers, freight ships, and oversized container ships use this passage constantly to reach Saint-Nazaire port. Every year, 2,300 ships deliver more than 30 million tons of goods. The economic challenge was huge.
La commande, c'était surtout de respecter et de maintenir les conditions d'exploitation du grand port. Et il est absolument inenvisageable de restreindre le chenal d'accès. Et le pont de Saint-Nazaire a été construit autour du gabarit qui a été donné par le grand port. Et il s'agit en aucun cas d'y déroger.
The center of the edifice had to be a gigantic door left open on the Loire. The dimensions of this vast stride were imposed by the port, a minimum width of 980 feet and a height of 200 feet, the equivalent to 3 consecutive soccer pitches. The project became as ambitious as it was oversized. In 1971, the engineers in charge of the conception had to determine the structure capable of such exploits. They had to study the most adapted shape and especially the materials composing it.
L'ouvrage avait 2 défis de construction, la longueur de l'ouvrage et la nécessité de franchir un chenal qui était de plus de 300 mètres.
C'est là en fait où la mécanique et la résistance des matériaux nous permet de dire que le béton armé, on ne peut pas le faire. Un béton armé, c'est très efficace, très économique, mais sur des portées d'une quinzaine de mètres.
The 50 feet or so of concrete span are sufficient as long as piers come to support what is known as the deck of the edifice at regular intervals, the horizontal part. But to cross 980 feet in one stretch, they had to look for other materials.
On passe à des structures qui sont plus souples, plus légères et qui sont à base d'acier. On va avoir un tablier qui va être léger en métal, donc très élancé, ce qui va permettre de dégager en dessous la hauteur libre du chenal navigable. Et puis pour le soutenir, parce qu'il ne peut pas non plus reposer sur aucun appui, on va venir le suspendre. Donc on est obligé de passer sur des ouvrages dits à câble. Et des ouvrages à câble, globalement, il y en a 2 types. Il y a les ponts suspendus et les ponts banés.
In the case of suspension bridges, like the Golden Gate or the Tankerville Bridge, the deck is attached by vertical rods to long cables anchored on the shore. Conversely, on cable-stayed bridges, all the cables are connected to the deck and supported only by its pylons.
On est en plein estuaire, donc il y a beaucoup de vent, on le voit aujourd'hui. Qui dit vent dit un milieu très sensible aux vibrations. Quand on est en ouvrage à câble, on a des ouvrages qui sont très souples, donc très sensibles à la vibration. Sauf qu'entre un pont suspendu et un pont banné, le pont banné il a un meilleur comportement vibratoire. Donc globalement, on va plutôt avoir tendance à prendre un pont banné.
The general design of the bridge was decided. First, it would be composed of 2-axis viaducts of concrete on either side, supported by regular piers and connected in the middle by a huge steel section. This cable-stayed part would be supported by robust cables, the stays, attached to 2 massive pylons. The worksite could now begin. On November 7, 1971, the Loire estuary became the theater of operations for about 4 years. An extraordinary worksite during which workmen, engineers, and craftsmen had to work on the water, suspended in the air, caught between the current of the Loire and the wind coming from the ocean. First step, positioning the edifice and setting up the work areas over the course of the bridge. But to make progress, they had to find shelter. In the middle of the river, the tides make the water level vary by 20 feet twice a day.
La première phase, c'était de construire une enceinte, une périphérie autour des semelles qui étaient faits avec un rideau métallique, ce qu'on appelle des pales planches.
Ces pales planches ont permis déjà d'avoir des zones de travail saines. Donc une fois qu'on a asséché en partie la zone, qu'on a remblayé avec du sable de Loire et ce qu'on a appelé du gros béton pour être en zone saine, on est venu ensuite créer nos fondations.
"54 independent work sites were scattered over the estuary, as many areas needed where the bridge would be supported. Before rising in the air, they had to anchor the edifice's legs into the ground solidly. These foundations were crucial. They would carry the largest bridge in the country. Their construction required considerable preparation.
On a déjà pré-positionné nos appuis en études préalables et puis on vient faire des sondages au niveau de ces appuis pour venir vérifier qu'on a bien le type de roche que l'on souhaite, à quelle profondeur d'ancrage et avec quelle performance mécanique. Et il faut que je vérifie que l'ensemble des charges supportées par mon ouvrage et par son poids propre, en fait, et peut bien être prise par le sol rocheux. Sinon, on a une rupture de sol et l'ouvrage peut s'effondrer.
The studies highlighted a particularly complex and variable geological profile. On the river shore, they could dig 30 feet or so. But in the middle of the Loire, where the main piers would be placed, they had to go through 150 feet of loose soil made of sand and silt before finding rock that was capable of supporting the weight of the structure.
Ce contexte géologique imposait d'avoir des fondations dites des fondations profondes, qui ont donc été des fondations sur pieux.
Once they had settled on their work areas, the teams positioned the gigantic piles of 5.9 feet of diameter and sank them into the ground. 4 piles were enough in the more modest parts, but 18 were necessary in the central piles. These piles were positioned with precision down to an inch. They could reach 160 feet long and had to be filled with 160 cubic yards of concrete to give them their solidity. An incessant ballet of barges got organized. The concrete was made on the shore, then brought up to the different foundations while being mixed on the way.
Toute la construction s'est faite par voie nautique, donc les bétons étaient approvisionnés par des toupies montés sur des barges. Donc ça, c'était quand même une vraie difficulté.
This was a sensitive operation. It had to be pursued in all weather and coexist with the river traffic that couldn't be interrupted. Between Nantes and Saint-Nazaire, transporters sailed continuously and the huge port couldn't be disturbed. After over a year of work on the foundations, the bases of the edifice were now solidly anchored in the riverbed. Now came the time to build the bridge's legs, to erect what is known as piers. Reinforced concrete supports that would measure from 10 to 190 feet high. The great waltz of concrete was nowhere near finished.
Ce qu'il faut avoir en tête, c'est qu'on ne fait pas une pile tout d'une traite. On fait un premier plot de ferraillage, coffrage, bétonnage. Et une fois qu'on l'a fait et que le béton il est monté en résistance, on va faire ce qu'on appelait des coffrages glissants. En fait, on avait des coffrages qui venaient glisser sur une pile, on redémarrait, ferraillage, coffrage, bétonnage, monté en résistance. On repositionnait les crémaillères et on montait le coffrage. Donc toutes les piles se sont faites avec des coffrages glissants montants.
Gradually, the piers emerged and took shape. The 54 supports drew the outline of the bridge over the entire width of the estuary. structures ready to contain the 2.1 miles of viaducts that would form the longest bridge in France. The first elements of this horizontal part were elaborated on the shores. Gigantic beams of 170 feet long that would connect two piers. 4 of these were necessary to form the width of each section. Together, they formed what is known as a span. To give more solidity to these concrete beams, a metallic frame was also necessary. But over such lengths, the reinforced concrete technique wasn't sufficient. They had to add what is known as pre-stressing.
Lorsqu'on veut augmenter la portée d'une poutre, il y a un moment le béton armé en fait va être trop lourd et donc on est obligé d'avoir une autre technologie qu'on vient ajouter qui s'appelle la précontrainte. La précontrainte, c'est ni plus ni moins qu'une barre en acier qu'on met à l'intérieur de notre poutre, qu'on vient triller très fort. Et quand on la lâche, en fait, aux extrémités, elle va venir, en voulant se rétracter, elle va venir comprimer la pièce.
Here, steel cables were previously placed inside the beam. When the concrete was partially dried, jacks were placed and pulled on the cables with phenomenal strength. Then, they were released and came to compress the entire beam. This compression gave it greater resistance.
Prenez 10 bouquins entre vos mains. Si vous appuyez pas très fort entre vos mains, tous vos livres vont tomber. Donc la précontrainte, c'est ni plus ni moins que ça.
Ready to withstand their own weight and the road traffic more specifically, these 190-ton beams now had to be positioned above the river. 208 elements in total had to be installed.
Une fois les poutres préfabriquées au sol sur la zone de chantier, il faut les mettre en position au-dessus des travées. Donc on a construit l'ouvrage travée après travée à l'avancement.
To manage this, the construction teams of the Saint-Nazaire Bridge resorted to use a peculiar machine, the beam launcher. This colossal 480 feet long machine was one of the keys of the worksite. It was designed especially for this occasion, and only this could move the gigantic beams manufactured on the shore.
On avait un système de lanceurs qui étaient en fait des sortes de portiques en treillis métalliques sur des systèmes de roues et qui avançaient. Donc en fait, ces portiques étaient de la longueur de 2 à 3 travées. Et en fait, ça permettait de porter une poutre, l'amener entre 2 piles, la déposer, avancer, amener une autre poutre, déposer les piles, les poutres, etc., etc.
The length of the launcher, 480 feet, allowed it to rest on the last section created and hang over the void while resting on the pier ahead. Once in position, a beam was placed in the middle of the launcher. 2 highly powerful lifting gantries grasped and lifted it. They slid along the metallic structure and placed it on its neck supports. They had to repeat this operation 4 times to place the 4 beams of each span side by side. They were joined together and had made progress of 170 feet. The barriers and handrails were installed and the launcher got prepared for a new cycle. Day after day, the 2 huge concrete viaducts advanced over the Loire. They gradually drew the outline of the Saint-Nazaire Bridge. Back then, around 100,000 cubic yards of concrete, that's about 30 Olympic swimming pools, were necessary to erect the piers and build the first part of the deck of this gigantic bridge. Today, seeing this edifice tower above the Loire, you might think that this mass of concrete is invincible. However, 50 years after the start of its construction, the biggest bridge in France has faced time and the elements. Like all works of such size, constant monitoring is necessary.
Qui dit ouvrage exceptionnel d'une époque dit que des années plus tard, en termes de maintenance, on a des choses qui apparaissent qui sont la réponse d'un domaine qu'on a poussé à ses limites, de connaissances en tout cas.
The experts in the civil engineering department have the heavy responsibility of ensuring the bridge's smooth stability. This is a huge task.
Un pont, c'est une structure mécanique et technologique. Et pour s'assurer de son bon maintien, il faut aller le voir régulièrement, sous toutes les coutures en fait. Un peu à l'image du médecin généraliste. Il faut prendre rendez-vous régulièrement avec lui. C'est que pour connaître notre ouvrage, il faut le surveiller.
Every day, patrols survey the bridge, looking out for the slightest sign of wear and tear, and important maintenance operations are programmed at regular intervals. Every 3 months, every year, every 3 years. The frequency depends on the scale of the works. Among the specialist priorities, surveying this omnipresent concrete is crucial. In the middle of the estuary and facing the ocean, the structure is subjected to the constant assault of water and salt. Over the decades, water seeps inside the concrete, bringing with it chloride ions from salt. These chloride ions may then attack the metallic structure of the reinforced concrete.
Le béton, c'est un matériau qui reste poreux. Donc on a un phénomène de pénétration de ces ions dans la matrice de béton et qui, avec le temps, avance et arrive jusqu'aux armatures. Sauf que l'acier et les ions chlorure, ça fonctionne très mal. On a des phénomènes de corrosion par dissolution. Et les produits de corrosion, comme c'est des produits gonflants, viennent faire fissurer le béton. Et donc potentiellement, on peut avoir un ouvrage qui, si on le laisse péricliter dans le temps avec des armatures qui sont toutes corrodées de partout, on peut avoir un ouvrage qui a plus sa capacité portante telle que designée au début.
They must inspect the edifice in all its nooks and crannies, check the presence of corrosion, and react in time. Some areas are identified and must be repaired.
L'arrivée des chlorures n'est pas uniforme sur toutes les parties de béton de cet ouvrage, mais des fois, on va avoir un foyer de corrosion plus important à certains endroits, qui nous amène à intervenir après en intervention, en réparation. Et il faut purger ces bétons pollués, remplacer l'acier si vraiment il a été trop corrodé, et puis après apporter un béton neuf.
Once the structure has been repaired, adding new technical mortar shuts the door on corrosive elements. These concrete joints will play a protective role over the decades to come. But the civil engineering experts continue to constantly monitor the evolution of these corrosion sources. Through surveillance and observation, the experts have detected a more sensitive area than the rest of the start of the South Viaduct. A place where the corrosion of the concrete frame seems to cause more consequent problems.
Pour le viaduc sud, c'était au cours d'une inspection, d'un contrôle annuel. Il y avait une poutre qui n'était pas comme d'habitude. Et il y avait un gros éclat de béton, et c'était pas non seulement un éclat de béton, c'était que derrière le béton, on voyait la gaine de précontrainte qui était abîmée déjà. On voyait déjà quelques fils qui étaient cassés, qui étaient rompus. Donc une perte de capacité de la structure.
Here, the ocean spray not only made the steel swell and damage the concrete, it came to gnaw at the pre-stressing cables, those that compress the beams and give them their resistance.
Le jour où la précontrainte a des problèmes, c'est-à-dire qu'on diminue l'effort de compression, forcément on va commencer à avoir des poutres qui vont potentiellement tomber.
Puisqu'on avait un défaut de capacité mécanique, il fallait apporter un renfort mécanique pour conforter l'ouvrage.
The experts of the department had to imagine a process to compensate for this loss of resistance to the structure. Impossible to operate inside the beam. So they decided to add a pre-stressing effort on the outside.
On a notre poutre qui est au milieu, qu'on doit renforcer. On peut mettre de la précontrainte de chaque côté, qui va venir comme un serre-joint de part et d'autre, qui va venir rapporter la compression qui s'était libérée par le défaut de la précontrainte d'origine.
These large black tubes were positioned on the critical area, but also on the entire South Viaduct. They came to compress the structure and give it back its bearing capacity. Thanks to this device, the resistance of this part of the bridge is ensured. But the rest of the edifice leaves no respite. They must constantly follow the evolution of the edifice and examine the slightest detail. Concrete, steel, cables, equipment. Every element requires constant vigilance. Back to the construction of this gigantic bridge. While the concrete parts of the edifice had been completed, let's look at the creation of the metallic part. From the start of the construction, this cable-stayed section caught everyone's attention. This would give the edifice its final appearance, and other than its French record of length, it would break the span world record for cable-stayed structures.
À l'époque, il faut avoir en tête que c'était une conception essentiellement portée par des ingénieurs. Et donc, finalement, toute l'architecture du pont de Saint-Nazaire était dictée par des contraintes plus techniques et des contraintes technologiques, plus qu'un design d'architecte.
Originally, the idea was to leave a passage of at least 980 feet wide under the bridge so as not to disrupt the harbor activities. But when they drew a straight line between the expected north point and south point, the engineers at the time faced a geometrical problem. The bridge cut the channel at an important angle. To keep the 980 feet wide in the axis of navigation, they had to increase the span of the central part. The 980 feet at an angle turned into 1,600 feet in the bridge direction. But in 1971, crossing such a distance in one stretch was technically unthinkable. The teams back then had to find the best compromise.
Pour réduire en fait la portée, il fallait essayer de diminuer le biais entre le franchissement et l'axe du chenal. Et on a donc essayé de réduire ce biais, d'essayer de passer le plus perpendiculairement, en créant ce S qui diminue effectivement le biais et permet de réduire la longueur.
The engineers had to redesign the course of the bridge to make it cross the sailing channel in a more perpendicular way. They finally succeeded in finding a span for the central part, which was at the limit of what seemed possible at the time, 1,300 feet for the span of a cable-stayed bridge. The Saint-Nazaire Bridge is the result of a subtle compromise between constraints, technology, and ingenuity. A decision that ended in a world record span and this S-shaped line that have made it characteristic. A prowess that we will now materialize. Since the start of the work site, the production of steel elements composing this gigantic cable-stayed part was made in parallel. A necessary organization to save precious time. In total, they had to produce twice as much steel as the Eiffel Tower required.
Il y avait bien deux chantiers, le chantier travée-béton et le chantier de l'ouvrage métallique. Donc le chantier béton avait sa cadence de préfabrication et de mise en place. Le chantier métallique avait lui aussi sa cadence de fabrication du tablier métallique en usine. Mais les deux chantiers, on va dire, étaient indépendants.
The production of the different elements of the metal deck was spread out over the country. But the crucial part of the assembly took place in Fos-sur-Mer, near Marseille. In this factory, the production was continuous. Thousands of tons of steel were cut, shaped, and welded on location. Elements ranging from 52 to 310 feet came out and had to be delivered to the main worksite. To move such massive parts, the sea was the only option. They had to cross the Mediterranean, go through the Strait of Gibraltar, and sail up the Atlantic coast. A journey of over 1,900 miles requiring 11 to 18 days at sea, depending on the ocean's whims.
Les tronçons étaient fabriqués en usine à Fos-sur-Mer, étaient envoyés par bateau Donc ça faisait le tour de l'Espagne, de Gibraltar, ça remontait jusqu'à l'estuaire de Saint-Nazaire. Et puis quand ça arrivait ici, on soudait les morceaux entre eux.
Once they had reached Saint-Nazaire port, the parts were assembled into huge steel structures. The most imposing ones were those called end spans. These 630 feet long elements formed the ends of the metal deck positioned on either side of the pylons. Their installation was now imminent. The first step was to bring these end spans from the Saint-Nazaire port to the work site. The convoy had to leave at low tide to reach the middle of the estuary at high tide. It carried one of the steel spans and the pylon that would tower above it. Once on location, the span was fixed to the last pier of the concrete part on the one side and locked between the foundations of one of the main piers on the other. They then had to erect the rest of the main pier before sliding all of this to hoist it above the Loire. The importance of the central piers was colossal. In the end, they would support the pylons and thus all the metallic part of the bridge thanks to the 72 stays attached there.
Les piles principales reprennent toute la descente de charge du tablier et des haubans. La conception de ces piles, de ces fûts de piles, tient compte de tous ces efforts.
Il faut imaginer, c'est comme si on avait chacun des haltères très très lourdes de chaque côté. Donc nos bras, c'est les haubans. Notre buste, c'est le pylône. Et puis les jambes, c'est la pile. Donc la pile, elle reçoit énormément d'efforts. Et il faut descendre ces efforts-là jusqu'aux fondations.
To anchor them in the riverbed, it wasn't 4, but 18 piles of 5.9 feet of diameter that were necessary. These were also composed of 2 concrete cells that let the huge metallic spans through to be hoisted. These 2 cells were then united by a concrete shell once the construction was completed. The fabrication of one of these main piers was coming to an end. It culminated at precisely 190 feet high. The metallic span and the steel pylon embarked with it were still at water level. All of this weighed more than 1,700 tons. An ingenious rack system helped to hoist all of this gradually.
Ce système de charpente de hissage va supporter le tablier et est un système à double effet, c'est-à-dire la charpente a 2 niveaux. Elle s'appuie d'abord sur la partie basse, elle lève, elle prend appui sur la partie haute. On ramène la partie basse et par un système de vérin, d'aller-venue de la charpente, on arrive à monter.
2 platforms were positioned on either side of the span. They were made up of 2 parts connected by a system of jacks. The lower part was first attached to the structure, and the jacks came to rest on it to push the top part up. They lifted it 35 inches. Then the top part was attached while the jacks hoisted the lower part that came up in turn. The lower part was then attached again and a new cycle began. On the other end of the span, the same operation was carried out, but with a slight delay, bringing the part horizontally at every cycle. After 4 days and 44 lifting cycles, the huge metallic span had reached its final position. Now came the time to install the pylon embarked with it. Tension was palpable. The role of these steel giants was crucial. These were the centerpieces of the edifice.
Le rôle du pylône, lui, c'est de tenir tous les haubans et le tablier. Donc s'il n'y a pas de pylône, il n'y a pas de haubans, il n'y a pas de tablier.
To put it in position, they had to raise it in one go, until it reached a vertical position. 285 tons spread out over 220 feet. The shift had to be mastered precisely.
Il faut donc relever le pylône. Ça se fait à l'aide de mâts de mâts provisoires, de charpente, et puis de systèmes de câbles, et de contrepoids pour maîtriser la rotation du pylône lorsqu'on le lève. On le positionne et on le met dans l'axe de ses appuis, sur la ligne d'appui.
The operation couldn't proceed with approximation. They had to act slowly, but surely, so as not to lose control of the movement. Gradually, the huge red and white structure lifted. When the operation was 2/3 of the way in, a 20-ton counterweight was added to avoid any risk of toppling. Once at the end of its course, it was perfectly aligned with the corresponding main pier. Here, it was ready to tower at 430 feet above the Loire, a colossus guarding the gate of the estuary. It had now been more than 3 years that the teams had been working hard to build what would become the biggest bridge in the country. The works were coming to an end, but the grand finale had yet to be accomplished, assembling the central part. The 1,300 feet of metallic deck that would be connected to the pylons, towering over the sailing channel and joining both parts of the bridge.
Le pont de Saint-Nazaire, c'est lui, c'est cet ouvrage métallique, ce ruban métallique haubané.
This central metallic deck would be composed of 20 sections of 52 feet each. They embarked on the Loire from the port and were placed immediately under the bridge. Here, a winch was placed to hoist them up to their final position. These 100-ton pieces flew up 200 feet above the river. In turn, they were connected to the part of the edifice that was already built. Then came a particularly delicate stage. The sections had to be connected to the pylon with stays gradually. These huge cables of 2.8 inches of diameter were decisive for the entire structure of the edifice.
Ces 72 câbles retiennent l'ensemble du tablier métallique, donc le poids propre du tablier métallique, mais aussi toutes les surcharges liées aux équipements et à l'exploitation de l'ouvrage, donc les surcharges routières. Donc ça retient énormément d'efforts.
All the stays were attached to the top of the pylon and anchored on either side of the deck. On the shore, where the edifice was already in place, and on the central side where the bridge was being built gradually. They had to adjust the tension of each of these stays so as not to compromise the solidity of the structure. A subtle game of balance.
Donc tout est lié en fait. C'est une mécanique qui est assez fine puisque en termes de répartition de charge, il faut savoir que tout est équilibré en fait. Si on commence à déséquilibrer des haubans, donc si on tire très fort d'un côté du pylône, le pylône il va avoir tendance à partir d'un côté, ça va déséquilibrer l'autre côté, donc on va avoir le tablier qui se soulève. Donc tout est minutieusement réglé.
Other than ensuring the bridge's smooth realization, this adjustment of stay tension gave the edifice the desired profile, the right slope at the right place. The central part made progress from each pylon until they met in the middle. The last section was positioned with precision down to an inch. It completed the 2.1 miles and 4 years of construction of the longest bridge in France. "50 years after the start of construction in 1971, the Saint-Nazaire Bridge fulfills more than ever its role as a link between the two banks of the Loire.
Le pont de Saint-Nazaire, c'est le seul ouvrage entre Nantes et Saint-Nazaire qui permet de traverser la Loire.
While the provisions back then estimated traffic to be 5,000 to 6,000 vehicles a day, today it's more than 35,000 that drive by. More than 11 million every year. A flow of heavy trucks, workers, and tourists, which must be maintained at all costs to ensure the economic activity of the great port, the shipyard, and the entire region. Hundreds of international-scale companies depend on this. This constant traffic is managed in real time by the traffic monitoring service located in Nantes.
Tout est normal sur le portique? Ah, sur les deux voies en plus? Ok, ben j'envoie la patrouille tout de suite.
Operators ensure the safety of users 24 hours a day, 7 days a week, thanks to 23 dedicated cameras. They are in permanent contact with the different security services.
À ce moment-là, je vais essayer de t'envoyer les pompiers.
But seeing the considerable increase in traffic, the services of the department have had to renovate. Since 2010, the bridge is the object of a unique experiment in France and Europe. The goal, to adapt to traffic conditions live and make traffic more fluid.
Sur le pont de Saint-Nazaire, en 2010, il a été décidé d'installer un système dynamique d'affectation des voies. En fait, il faut savoir que c'est un pont à 3 voies de circulation et on est capable en temps réel et en fonction du trafic d'affecter la voie de circulation, la voie centrale, de l'affecter dans un sens ou dans l'autre.
Out of the 3 lanes of the bridge, 2 are assigned to a direction of traffic flow and the other to the other direction. When necessary, the operators of the traffic monitoring service are capable, from Nantes, of changing the direction of the central lane in around 20 minutes. They favor the crossing of the bridge in the other direction. To manage to do this safely, a battery of equipment was deployed on the bridge and 1.2 miles around it. Display panels, lane-changing barriers, gantries, and thousands of lights indicating the active lanes. As soon as the decision to change directions is taken, the operators check on their screens how feasible this is and trigger the different stages one by one.
Je lance mon basculement maintenant.
Il faut savoir que ce système a permis de gagner énormément de temps pour les usagers de cet ouvrage. Avant 2010, il fallait en moyenne 45 minutes pour passer le pont le matin et le soir. Et aujourd'hui, il faut entre 7 et 10 minutes. Donc voilà, le système a fait gagner plus d'1 heure de vie privée, on va dire, aux usagers du pont de Saint-Nazaire.
This original system optimizes the constant traffic in the best possible way. It makes traffic fluid on the bridge and as such in the entire region. By adding this system to all the equipment and sensors of the bridge, it is also highly useful in terms of security.
On a des stations météo qui sont dédiées sur l'ouvrage, qui nous permettent de savoir en temps réel la vitesse du vent qui est tout en haut de l'ouvrage, donc on est à plus de 60 mètres d'altitude. Ce système nous permet de sécuriser vraiment le passage des usagers en sachant qu'au-dessus de 80 km/h en rafale, on va fermer la voie centrale, ce qui va permettre de sécuriser des écarts potentiels d'usagers. Et au-dessus de 120 km/h en rafale, on ferme l'intégralité du pont.
In the middle of the estuary, facing the ocean and perched at 200 feet above the water level, the wind is a fearsome enemy for traffic. But it can also challenge the very structure of the bridge. Although concrete tends to stand straight facing the wind, the metallic section of the bridge, the vast cable-stayed part, is far more sensitive to the movements of air masses.
Il se trouve que l'ouvrage métallique, le pont haubané, c'est un ouvrage souple, donc c'est quelque chose qui respire, qui vit. Donc autant le tablier va avoir des mouvements, les haubans aussi vont avoir des mouvements assez souples, et ils peuvent être sollicités et mis en mouvement notamment par les vents. Ça peut être les tempêtes, mais pas seulement les tempêtes. Certains régimes de vent qui peuvent avoir une certaine irrégularité, qui vont le faire entrer en résonance.
Other than extreme phenomena, more usual winds can make the structure vibrate regularly, a phenomenon that can amplify gradually. The wear of certain pieces must be carefully examined, particularly the stays. It's on the highest part of the edifice that the attention is carried first, at the top of the gigantic pylons. Like all the corners of the bridge, this area is regularly inspected. They must climb about 20 ladders in a narrow environment to finally peak at 430 feet above the Loire. At the top, a breathtaking view over the estuary and the bridge unfolds. It's also one of the best ways to check the condition of the stays and their anchorage at the top of the bridge. This is where all the load of the metal deck is balanced on either side.
Un câble de haubans, il faut avoir en tête que c'est une structure souple qui est attachée au tablier avec une structure très massive, très rigide. Donc si votre câble il rentre en vibration, avec des phénomènes de turbulence de vent, en fait, il va commencer à s'agiter autour de la pièce massive, et donc potentiellement, il va venir se pincer. Et quand vous faites ça avec des cycles très répétés, on entre dans un phénomène qui s'appelle la fatigue, c'est-à-dire que l'acier, à force d'être toujours pincé, toujours sollicité dans cet endroit-là, en fait, il va se rompre.
The constant observations of the bridge demonstrated that one of the gigantic steel cables was damaged. Stay number 32. However, it was much more simply on the side of the road than the anomaly was detected.
Ce qui s'est passé sur le hauban 32, c'est qu'à l'occasion d'un contrôle par les équipes du service en charge de la surveillance de l'ouvrage, on a pu détecter des boursouflures au niveau du hauban 32 dans sa partie d'attache avec le tablier. Et ces boursouflures étaient révélatrices de fils qui s'étaient rompus et qui commençaient en fait à partir un petit peu en champignons au niveau de l'attache.
This stay has already been changed in the past, but the phenomenon continues. A mystery that the specialists would like to uncover and that is essential to control. The civil engineering teams have set up a specific surveillance device. Each stay is composed of a multitude of braided steel lines. To monitor the evolution of Stay 32, the teams have developed a system of detection of a potential rupture of one of these lines. This is acoustic surveillance. 3 sensors have been placed on distinctive areas of the stay. They are sensitive to the slightest sound vibration. If one of the braided lines break, a sound wave will go over the stay and be picked up by sensors. According to the nature of the signal on the different sensors, the team can deduce the location and importance of the break. Thanks to this device, surveillance is live and permanent. A guarantee of security, but also a way of better understanding this mysterious phenomenon of wear.
Manifestement, c'est l'orientation particulière. Il est au mauvais endroit par rapport au vent dominant. Il s'avère qu'il est sollicité en vibration plus que les autres. Les haubans vibrent, c'est normal. L'ouvrage métallique bouge, c'est normal. C'est une structure souple. Mais en l'occurrence, ce hauban bouge plus que de raison.
The safety of the edifice is far from threatened, but the experts remain on the lookout as to the future of Stay 32. While they wait to shed more light on this, they continue to monitor the edifice, all over the bridge, by day and by night. It's 11 p.m. Exceptionally, the bridge is about to close for the night. A few hundred yards away from one of the access roads, a team of surveyors is getting geared up and adjusting their tools. In a few minutes, they will access a site emptied of its traffic to carry out what is known as an altimetric survey, a precise measure of the bridge's shape as a whole.
L'idée est d'aller relever la géométrie de l'ouvrage sur tout son linéaire, prendre une photo de son profil altimétrique pour le comparer au levé qu'on a fait précédemment. Donc là, on s'est engagé sur une fréquence de 3 ans. Donc tous les 3 ans, on vient faire ce levé altimétrique.
The surveyors engulf on the bridge and spread out over the entire site. They have until 4 a.m. to carry out their records. In pairs, they must measure the height, or rather, the altitude of several hundred markers with a precision down to half an inch.
T'as une marque blanche et juste à la marque blanche. Ça va?
Points determined in advance, and the same ones from one measuring session to the next.
En prenant toujours le même point au même endroit, à part si le pont bouge, on n'aura pas d'écart signalé. On fait ça du coup tous les 3 ans, donc c'est assez fréquent quand même. Et du coup, on le fait ça assez régulièrement pour vérifier constamment en fait que le pont bouge pas.
Once they have measured all the marks, they can be analyzed, compared to the previous ones, and help check the evolution of the structure's geometry over time.
Ce qui peut aller interférer la géométrie, c'est tout ce qui fait que l'ouvrage bouge. Alors est-ce que c'est une poutre qui fléchit? Est-ce que c'est une pile qui s'enfonce? Est-ce que c'est un haut-banc qui se rallonge? Est-ce que c'est... On fait une radiographie, puis on compare les deux radios, puis ah tiens, il y a quelque chose qui est différent de d'habitude.
This method is essential to ensure the edifice's smooth development and plan the future maintenance operations to be carried out. Constant monitoring of the longest bridge in France. "50 years after the first stone was laid, the Saint-Nazaire Bridge still ensures its crucial role of a link between the two banks of the Loire.
C'est le seul pont entre Nantes et Saint-Nazaire. Donc c'est un lien essentiel. C'est aussi, en contrepartie, un bel ouvrage public avec une obligation d'entretien.
A site whose scope demands constant vigilance, regular maintenance, and the daily involvement of the experts who are in charge of it.
On se sent tout petit face à ce pont et on essaie de rester humble dans nos approches pour essayer de faire en sorte que toutes nos actions elles soient compatibles avec son histoire, mais aussi avec ce qu'on veut en faire demain de cet ouvrage.
Thanks to all the civil engineering specialists, this colossal bridge has crossed time, facing the elements. Today, it has grown more modern, accompanying ever-increasing traffic.
On voit bien que l'infrastructure qui a été construite en 70 est capable de prendre beaucoup plus d'usagers que ce qui avait été estimé, et on a encore de belles années devant nous.
Encore aujourd'hui, c'est innovant. C'est ça qui est passionnant, c'est de travailler sur un ouvrage qui était une innovation déjà à l'époque et qui l'est toujours aujourd'hui.
The Saint-Nazaire Bridge has towered for over half a century in the mouth of the Loire. It remains the longest bridge in France and has also become essential in the lives of dozens of thousands of people. A site that went from an indispensable infrastructure to a real emblem of an entire region.